solve problems. So good enough, right? So the way I like to think about a question like this is I will think about 2032 single units, because I said that it's got, you know, A, B, C, D, and E, they can't be fractions, right? They can't be negative, they can't be zero. Actually, you know what?
It can be zero.
We can do it this way. If we do it this way, then there's going to be, I'm just thinking about it. Should I make it whole? Should I allow for a whole? Because if I allow for a whole,
Then you get zeros.
then I can have zeros, and I'm just thinking about the technique that I want to use. Just give me 1 second here, just to think about something. So if I have that, and then let's say, yeah, if I go like this, if I separate, let's say, a couple times here, then that would allow nothing of one particular choice. But if I do that, that's a different solution. Okay,
Can we do it both ways then?
yeah, we can do it both ways. I'm just thinking what's the easier way to do it first. I think we'll start with, that's good. No, let's start with whole. I think we'll start with whole. And hang on a sec, before we go on with, oh, no. Did I say natural? Natural starts at 1, right?
Yeah.
Yeah, okay, so yeah, we'll do natural first, because natural, I believe, is easier. So natural is 0, 1, 2, 3.
No, non-zero.
Sorry, 1, 2, 3, ... So then, if we do it that way, we're not allowing for the possibility that any number is a 0, right? So the way I would think of a scenario like this would be, we'll do the part B one afterwards, would be to say, let's imagine that over here we have 2032 ones. You guys with me so far? So if you add up all of those boulders, if every boulder represents a 1, then you get 2032, agreed? So really what the question is asking you is how many ways, well, you're going to have to split up the ones, 1, 2, 3, 4, 5, into 5 parts, agreed? You're going to have to split up the ones into 5 parts. So like maybe A will be a couple of ones, and maybe B will be 1,000 ones, and maybe C will be a couple of ones. But the bottom line is, whatever the split is, the sum of the split has to add up to 2032. So the question is really asking you, how many ways can you split this stuff up into 5 parts? You see that? That's what it's really asking you. How many of you guys follow that? All right. And so you could imagine, for example, that I want to take, let's say I want to let A be 3. Could A be 3, for example? Sure it could. That would mean I would take from here up to there. Agreed?
Yeah.
And then maybe B could be 1. So what this means visually so far is that this is a particular solution I'm drawing, but then we'll make a general case out of it. So far my solution says A is 1, 2, 3, right? And then I'm saying B is 1. Right? I could then say, I don't know, D is, let's let D be 2. So I'll stop over there. And then, oh sorry, I missed C. Let's make C 1, just because of the way I've drawn everything. C could be 1, let's say. I don't know, I'll make D 2. And then E is 2032 minus, what have we got? 2, 3, 4, 7. Is that 7 right there? No, 5, 6, 7. So 2, 2, 5 is it? So then this is 2, 2, 5. You guys see that? Now, that, you guys agree that that's one solution set? So that answer corresponds to 3, 1, 1, 2, 2025, right? Of course, there are many others, right? There are many other solution sets. So then the question becomes, how many ways can I bust this whole thing up such that the sum of the parts gives me back all of the boulders? Does that make sense so far? Yeah? So then, based on this question, which says natural, we're not allowing the bypass of any letter, agreed? Because if I was to bypass a letter, that would mean it would be a value of 0, which violates the rules for naturals, right? So I can't pull one of these moves. Like I can't go like that and then put a bar right after the bar in between. Because that would mean visually that you're allocating a 0 to B. You know what I mean? Do you guys follow what I'm saying visually? Like if I could have, let's say I put a bar here. I cannot put a bar right here beside it, right? The next bar has to go over 1 because that means I'm at least giving B a value of 1. If I put a bar here, I'm going to think about it as, oh, I gave A 1 and B nothing. Which is a possibility that we can do for another method after. So, what we're basically saying, did I confuse you guys with that? What you were basically saying then is bars can only go in between boulders. Agreed? Bars can only go in between boulders. And a bar cannot start behind a boulder based on this specificity. Right? Because you want to automatically allocate a value to A and every other number that's 1 or greater. So we can imagine a slot for a bar after each boulder starting after the first, where bars are allowed to live. And I guess, is a bar allowed to go over here? Yes or no? How many of you say yes? 1, 2, 3, 4, 5. How many of you say no? 1, 2, 3, 4. Okay. Well, if I was to allow a bar here,
So there's nothing left in the right.
there's nothing after it, right? So I
There's
think,
no number for it.
yeah, I think, well, let me ask you this. I think this will clarify the answer that you want to give. Based on what I've explained, put up your hand, don't blurt it out. Jujuan, how many bars do you think we would need? 4, you think? I think 4, because look, how many do we use here? 1, 2, 3, 4. So actually, because if you have a clump, let's say behind each bar, right? So if you have 4 bars, you have, by doing a division here, you've allocated to an A, second bar to a B, third to a C, fourth to a D, but then everything to the right of that 4th bar is allocated to the 5th group. So you actually only need 1 less bar, right, than the total number. You see that? Because everything to the right of that last bar gets dumped to the last letter. If that makes sense. So, given that, now, how many of you think that a bar can live to the right of the last boulder? How many of you say no, it can't? You're allowed just one like this. Okay, anyhow. So I would say, yeah, you can't have one here.
So the first place and the last place we
So-
talked and
Yeah, so I guess now we have to see, well, how many... It seems as though we have a slot. Shh, don't blurt stuff out. Put up your hand. It seems as though we have a slot following each boulder, except we don't have one following the last boulder.
Yeah.
So how many boulders are there? 2,032 boulders, right? But now how many, Aaron, slots do we have?
4 or 5.
Slots.
Slots?
Yeah.
5.
How many boulders are there?
2032.
And so then how many?
2031 slots.
2031 slots, right? So you have 2031 slots. You have slot 1, you have slot 2, slot 3, slot 4, slot 5, slot 6, slot, I guess this is how many we're at, 29, 20, no, 30, 132. 28, 30. So we have 2032 slots, and
It's supposed to be 2030.
oh, 31. Yeah, you're right. You're right.
What if only the order of the bar, there's not order of the second.
Now, this is again one of those situations where you actually have less items than positions or slots, right? But the logic I taught you is the same. You just flip it around. Instead of allocating, you know, if you have 9 people and you have 6 slots, how many ways can you allocate 9 to 6? You say 9p6. Well, obviously you have less people or bars than slots. You can't possibly fill up all of the slots, but you can use the same logic in reverse. Because you can say, how many ways can I allocate 4 of these 2031 unique slots to these 4 bars? In other words, which of these 4 am I going to use up? If I use up the first 4, that gives you 1 unique set. That means A equals 1, B equals 1, C equals 1, D equals 1, and E equals 2032 less 4, which is 2028, right?
Yeah.
So, depending which 4 of the unique 2031 you take, which group of 4 you take, will give you a unique solution. Does that make sense? It's just, you just visualize the 4 sticks dropping into 4 slots. And depending on what configuration of 4 slots you grab, that will give you a unique solution. So then, Brajesh, based on everything that I've just said, you guys are so silly. What do you think the answer would be? I said Brajesh. You didn't get any of it? German?
Okay, 2031, choose 4.
Now, why isn't it 2031 P4? German.
Because we get,
German!
okay, so we took 1 position out because they're 2032. And
Yeah, I know, but why is it C, not P?
Well, because the order doesn't, no, wait, the order matters, right?
Leave him up, guys, you're like freaking hyenas. Let the man think for 2 seconds.
Okay, so the order
Let him
doesn't
breathe.
matter.
Huh?
The order doesn't matter.
Right, in other words, if I wrote 2031 P4, then let's say I took this, and this. This answer would say that that is different than if I went this, and this. Right? But of course, those are the same 4 slots. So the order in which you choose the slots doesn't matter in terms of giving you a different unique solution. Only which 4 of the 2031 you take. Does that make sense? So you get a very fast answer. So now my question would be, part B would be, tweak it. Tweak, well, let's just say change A to whole. Is it whole? Does whole start at 0?
Yes.
So what do you think the answer would be for whole? Now you guys think about that, take a couple minutes. So now basically the difference is any one of those letters, or more than one, as many as 4, could equal 0. In other words, one possible solution would be 0, 0, 0, 0, 2032. Right? Now you're allowing the possibility of a letter equaling 0, or more than one letter equaling 0. You see? Do you guys understand the nature of the tweak? Yeah? I think you can use the exact same technique. What's really nice about stuff like this, what's beautiful about stuff like this is you're using something that's extremely visual, right? You're using a visual cue or visual method to really build a logic that ultimately is purely mathematical. But this visual nature is what kind of gets us to this method. And that's cool, and that's something you'll see in math a lot, right? We always talk about, well, a lot of times we talk about geometry versus algebra in terms of a way to solve a system or a solution. So very often visual cues help us come to purely mathematical solutions. And in fact, ironically, very often visual cues that we take in 2, 3 dimensions can be used to extrapolate more general solutions which aren't visual at all, like in 4, 5, 6, 7 dimensions. So even to go beyond, geometry or a geometric way of seeing things, you can use geometry to kind of infer something that you can't see later. Sometimes you can. So anybody have? Let me think about the answer for a second. Okay. Okay, I got an answer. Who had? You too?
Yeah.
What do you got, monsieur?
Okay, so we have to have 4 more zero circles on the left because 4 of the A, B, C, G have to be zeros and the other have to be like real number. And we have like 4 more positions to 2032. Then we subtract by 1 and this number choose 4 because they're like 4 borders. Like 4.
Okay, so you're saying two. What's your? This is Gehrman's. I was thinking about it differently, but let's see if it'll work. Okay, so you're saying 2,000. So you're gonna add how many? 5 0 slots.
4 because 1.
2031, 2035. So what's your answer? 2034. Choose 4. What's your answer?
Yeah.
What is it?
Okay, just like 2035, yeah.
Well, what's your answer, man?
2035, choose 4.
Okay, I'm gonna put it over here for a second because I don't. Yeah, give me 2 seconds. I'm not saying it's wrong. It's just hard for me to visualize. Here's what I'm going to do. I'm going to say my answer is, how many boulders are there? 2032? 2032. 2000 and... Shoot.
Sir, I'm wrong.
I don't know if that's right. I think that's my answer. But actually, isn't that just 2030? Okay, I'm not sure if that's right. Let's think about it. Could you have a scenario like this in this case? Let's think. Could you have 1, 2, 3, 4 bars and then all of the boulders? What would that mean? It would mean A is 0, B is 0, C is 0, E is 0, A, B, C, D. So that's too much, right? Because they're all A, B, C, D is 0, and then E is 2032.
Is it the same?
Can I finish now? Then we'll go back.
Come on.
So is that allowable?
Yeah.
Could you have, I don't know, 1 and 1, 2, 3 like that? That would mean A is 1, B is 1,
Yeah.
C is 0, D is 0, E is whatever. What about,
Basically, I have 4
to
slots.
be
for
careful
every
here, can I don't know if I can do this, I don't think I'm allowed to do this though.
You should be.
You are.
You are.
Yeah, I can, because that means A is,
2032.
B is,
And then 0, 0, 0.
C, yeah, so I can't do that. So for this question, guess what?
What?
Bars can, bars can go anywhere.
So basically, the.
So how many total objects do you have?
Well, wouldn't it be 2032 multiplied, 2034 multiplied by 4 since you have.
How many total objects do I have? I have 2032 boulders and how many sticks?
Oh, 4, 5.
4 sticks. 4.
So how many total objects do I have? 2030.
2.
2036 objects, right?
Why?
Two. Just explain the whole damn thing. Why? I just talked for 10 minutes. I'm using this.
2 minutes, sir.
Okay, there are 2032 boulders in front of you.
Yeah.
Okay, forget the slots now. I'm taking them out. They're
I
gone.
know the slot.
No, the slots are out now. Okay, they're gone.
I know they're on 631 slots.
Now, just 2032 boulders.
Yeah.
I'm putting 4 bars before all 2032 boulders.
Yeah.
What might that represent?
So.
A is 0, B is,
0.
C is 0,
0.
D is,
0.
and E is
Everything.
2000 and.
2032.
So
Ah, that's.
I can take 4 bars and put them right next to each other and put them before the boulders. Could I maybe put 1 here and maybe 3 here, right in between?
Yeah.
Could I maybe put 1 there, or 2 there, 1 there?
Yeah.
Yeah.
Can I put them all at the end?
Yeah.
Can I put some of them at the end?
Yeah.
Is there any restriction to the way I can put the bars in orientation to relative to each other or the boulders in this question? Is there any problem with
No.
where they can go?
No.
So they can go.
So now you're going to visualize 2036 objects, where 2032 of them are boulders and 4 of them are sticks, and you can jumble them up any way you want. Does that make sense?
Yeah.
You can just randomly place them any way you want in the lineup from left to right. And every unique looking lineup, visually distinguishable lineup, is going to represent a unique solution set. Can you tell the bars apart? No. So like if I go like this, bar, 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 is that different than if I took these 2 bars and I... No, they're all the same bar, right? Because they all represent the same function. If this isn't a taller bar, this isn't a shorter bar. And the boulders, like if I take these 2 boulders and I swap their position, does it matter? They're all 1s. So really what you're looking at, it's like if I asked you, how many different, how many visually distinguishable lineups can I create with 2028 A's and 4 B's, right? And the answer would be, well, there are 2036 letters, but 2032 of them are the same, and 4 of them are the same.
Yeah.
Right? Like how many unique spellings can you create with the letters in the word all? It's 3 factorial over 2 factorial. Right? So it's the exact same logic.
But that gives you a mouth error.
Yeah, I was thinking I probably picked something that's redonkulously.
Big.
Oh, but this is not right. What do I have to put here?
Factorial.
Oh, but wait a minute. Oh yeah, because think about it. This is going to give you 2036 by 35 by 34 by 33, right? I guess that's already massive. But it's kind of nice because as a tester,
Is that nice?
it's nice because,
You would bring my calculator.
no, but it means that if you don't have the logic, you can't fluke your way into this answer. In other words, this is the best you could do with the calculators you have, right? So from a test perspective, it's actually good for me as a tester. If I give you that, you do this, and you can be like, Mr. Segev, I can't get a final number, I'll be fine. Express your answer like that.
Could I type in, could you like error 1?
You're a smart ass, that's good. I should put, you have to show your work. That's very clever. The answer is error 1.
Well,
Yeah,
yeah.
no.
Simplify.
Error 1.
So you do get an answer if you do like 2034 times 2035.
Oh, so that means what it's doing is it's trying to crunch the whole top first, and then chop it down by the bottom.
Calculator.
So you can even still use your calculator.
So you're like 7.13 times 10 to the 11.
So did you guys follow that? Yeah? Does it make sense? It's an interesting technique. Are you going to see anything on this test that is going to be tricky? Yes, but like maybe one question or two, maybe.
Are the questions on the test going to be harder than the second one?
I got a question. Are the questions on the test going to be harder than the second one on the quiz? You might see one or two that are.
Just give me one, sir. I'll buy you lunch. Give me one.
We're gonna get one or two, probably half.
So you said you'll make the test easier because we're not moving it to Tuesday.
Yeah, you said that.
Yeah.
You said that, sir.
And then half of the class will drop if you give us.
I'll be happy if you guys.
Okay, I should probably write this test that doesn't exist. I'm going to start doing that. And then we move, and then you guys are going to be very happy. You know why?
Why?
Because after this, we move to very easy stuff because of the nature of the way it's taught. But for those of you that are interested, I created last year supplementary to it. Like basically, I like to teach everything from first principles, right? I don't like to just give you formulas. We want to, in academia, we want to always start from 1 + 1 and work our way up, right? Some of the stuff that they're going to be showing you, bless you, later on, that I show you next, as mandated by the ministry, just involves me showing you equations and formulas and not showing you where they come from. And the reason why is because you need to know some partial differential calculus for them, which is first or probably it's second year in calc, university. If you're in engineering science, it'll be first year, but if you're not, it'll be a second year. Chris, have you been to university? She didn't take partial. She didn't do partial derivatives at first. Did she?
Second semester, you started learning about that.
What is a partial derivative?
It's like almost like a fraction. You take a whole and you divide it into like.
What are you talking about?
What are you talking
Nonsense. Anyways, she probably didn't do it in first year. She probably dealt with partials in second year. Because I think first year is largely a review and an extension. So, anyways, and it also would involve partials with sigma notation. So for those of you that are interested, I basically created a supplementary where I teach you how to derive those formulas if you're a person that's interested in that stuff, and we can do that in like 2 or 3 lessons, like after school or something like that. And then what I do with that supplementary is it also branches out into, I figure since I'm there, I teach about gradient vectors and Lagrange multipliers, which is again probably second year. Those of you that are interested, I can show you that stuff. If you're not, it's fine, because you're not required to know that by any stretch, and it makes things easy for you. The next stuff will be easy. The only thing that will be challenging is I really like playing with sigma notation and proofs with sigma notation, so you might get a funky proof for me to ask you to do. Oh, but wait a minute, I'm not writing the next test, so
Oh yeah.
you don't have to worry about that. But I might give you a nice one, a nice sigma proof for your quiz. Oh, and then we have to talk about the assignment.
Oh shit.
The project.
Project.
Right.